Hello everyone, myself Dr. Sayanti Chatterjee, faculty of CSE AIML IoT RAI of VNR VJIT Hyderabad. Today I am going my third lecture on advanced machine learning and it depends on the maximum likelihood estimation. It will tells us about theory, intuition and the real world examples. Today my topic is based on the what is maximum likelihood, what is the difference between the likelihood and probability, what is MLE and log likelihood, what is the coin flipping example using the Bernoulli's distribution, example from the normal distribution, example of the exponential distribution for maximum likelihood estimation, maximum likelihood for linear regression, properties and limitations and alternatives. So what is maximum likelihood? Maximum likelihood estimation is a method to estimate the parameters of statistical model by finding the parameter values, make the observed data most probable. So what is this? This is the meaning that to estimate the parameter of one case of a statistical model. This is the backbone of machine learning. So if we have a statistical model, we can estimate the parameter by finding the parameter values that make the observed data most probable. So it was first introduced by Sir A. Fisher in the year of 1912 to 22. Given observed data, find the parameter that maximize the probability. What data give you the maximum probability from the data set? Widely used in statistics, the backbone of the machine learning and the economics works both for discrete and the continuous domain distribution. So what is probability? Probability have the fixed parameter. But what is the likelihood means? Likelihood means how many observed data is there. Actually, how many data is the probability, the sample test, but how many data is actually happening is called the observed data. Say we have a sea, and the sea there are 100 fishes, but whenever I am taking one fish, it is either a salmon or a sea bass. So observed data is this two, but fixed parameter is 100 data. What is the probability? Probability means what data X is likely. What does it means? That how many times the data may come. But the likelihood says that theta best explains which likelihood is most commonly in the probability. So both are in the opposite direction. So it sums or integrates to 1 over all x. There is no formula to the sum is to 1. So probability means all the event sum, if we add, it will always get 1. Likelihood doesn't have this type of thing. So example, if I tell P of HHH means 3 heads in a case, and probability of 0.5 of getting one head is 0.125, but there is no formula for this for likelihood. So what is the formula of likelihood function? Likelihood function means if there are n number of cases and the probability of n number of cases is p x1, x2, x3, x4 like that, and there are total number of cases is theta, we can write that product of individual probabilities are there. But here is one point, we are thinking all the methods are the mutually independent. Then as this is a summative product, it is a productive calculation, so that's why we are always prefer the log likelihood. What is the meaning of log likelihood? We are always taking the log of L theta, so that we can write log of summation of log of P of xi by theta y. It is very easier to calculate. Then what is the third step of MLE? We have to differentiate at every point to get the maximum value. Then only we can tell this is a maximum likelihood estimation. We can write theta underscore MLE. The maximum likelihood function is equal to argmax theta of L theta, or we can write argmax of summation of log P xi theta. So let's do it using a normal example, and this is called the Bernoulli's example for the maximum likelihood. Bernoulli's distribution always gives the two cases 1 and 0. If there are cases which have the two binary output, we always prefer the Bernoulli's distribution. So say we have a biased coin and we have done that 10 times, and we observe we are getting head, tail, head, like that we are getting 7 heads and 3 tails. What is the best probability of getting heads? So from the likelihood function, what you told from the previous problem, that whatever the cases, so we have only two cases. What are the cases? One case is head, one case is head, and another case is tail. So what is the getting the probability of getting head, number of head is 7. And what is the what is the events for tail? Tail events are 3. So first is the probability of p to the power 7, and 1p into p, actually the formula according to the likelihood, multiplication of all the cases. So p into p, so p to the power 7 for head, and 1 minus p means tail cases is 3. So for simplification we are taking the log, so we are getting 7 log p into 3 log 1 minus p. So next case we have to check that it is the maxima point, and checking the maxima and minima we have to check the differentiation. So dl by dp is equal to 7 by p minus 3 by 1 minus p is equal to 0. So if we because we are calculating the value, so 7 into 1 minus p is equal to 3p. If we solve it, we are getting the value p is equal to 7 by 10. Though from the value also it is a very easy question, we are getting also 7 by 10. So MLE estimates the likelihood value is 0.70. So this is one very basic example, but it tells about the steps of the maximum likelihood. So maximum likelihood problem, we can check this is the likelihood condition, and the likelihood estimates p is equal to 0.7, confirming the MLE. It will not go more than the 0.7. The 0.7 means if the coin had the bias, that if we are doing the 10 flips, 7 heads will come. Now we are going for another example. Say I have one class, and in the class there are 5 students, and the 5 students, the heights are the 170, 165, 168, 172, like that, and it is always going for a normal distribution. So we have to find what is the MLE for mu and sigma square. So we are checking what is the value maximum likelihood chance of the mu and sigma square. So how to calculate? We are using the mu and this formula of the log likelihood for a normal distribution, and the value is minus n by 2 log of 2 pi sigma square, like this. This is the value. So if when we have to calculate the MLE, what we have to do? We have to take the minima. So we are checking the maxima. So del L by del mu, we are calculating with respect to mu, should be 0. And here you can find mu is on, this is a constant term, so it will be 0, and this term has only mu, so it is coming 1 by n summation of xi this is the value, and if we are using this value, we are getting the value 170 centimeter. We can also calculate the value of mu, that 165 plus 170 plus 168 plus 172 plus 175 by 5 is the mu. But from the formula also we can calculate the value. Next is the formula of the, if we are checking the variance is 1 by n summation of xi minus x square. So we can also get this formula from the equation del L by del sigma square by calculating this equation. So if I going for the another example, so say we have a wait time scenario of a customer arrivals at a shop and it is always following a exponential curve. What is the value or what is the MLE with respect to lambda? As they told, it is an exponential curve. The value is always lambda e to the power minus lambda into xi. So what is the likelihood function? Likelihood function is the some multiplication of everything, so it is always following the exponential distribution, so it is the lambda e to the power lambda to the power n e to the power lambda summation of xi. So if we are taking the log, then it is coming n log of lambda. If we are taking the minus lambda into e to the power xi. Remember, when we are taking the log, we will always thinking log base e. Next, if I want to calculate the maximum value of lambda, how can I calculate? dl by d lambda, because we want to calculate the MLE for lambda and it should be 0. So if we are putting the n by lambda minus xi is equal to 0, if we solve this equation, we are getting that lambda is equal to n by summation of xi, or we can write there are the simple xi. So n into xi, so it is coming 1 by x. Why 1 by x? This one, because this is the x over tilt means it is the mean. So what is, we can also calculate what is the x value. That is 2 plus 5 plus 3 plus 8 by 4 by 5, 4.4. So what is the value of lambda? Lambda value is 0.2227 persons are coming per minute. So this is the result from the exponential distribution. Now we are checking from the, this is the formula how we can also verify the maximum for the special case. If it is 0, again if we are calculating d square L by d lambda square, it is coming that 5 minus lambda square should be less than 0, because you can remember this value is giving the minima or maximum point, but it is actually maximum or not. For checking that, you have to do the double differentiation. Double differentiation means this value should be less than 0. Going for the another example with a linear regression. So say one student is studying for 1 hour, one is 2 hour, 3 hour, 4 hour, 5 hour, and the exam score is also according to the amount of study, 50, 55, 60, 70, 75, and y is always facing the formula beta 0 plus beta 1 x. We have to calculate the curve so that it will fill. So first is the, what is the x mean? X mean is 3. What is the y mean? Y mean is the 64. So when we are calculating the x minus x and y minus y mean, how it is coming? 50, the basic is 64, so 14 into 1, 14 into 1 plus, what is the second value? 55 minus 64, that is 9 into 2 plus third case. What is the third case? 65 into minus 64, but it is 0. Then 70 into 64 means 14 into 2 again, and the value is ultimately coming as 75. What is x minus x squared? I minus x squared is already came as 10. Why 10? 1 minus 3 square 2. 2 square plus 1 square, 2 square plus 1 square. So it is coming as 10. So what is the value of beta 1? Beta 1 value is 75 by 10. What is the value of beta 1? Beta 1 value is given as 75 into 10 because it is a straight line equation, and straight line equation is always, that value is m. And what is m? M is equal to dy by dx. So using this value, we are getting the value beta 1 is equal to 10. What is beta 0? Y minus beta 1x. And why we are using the beta 1x? We are getting the value by calculating the 64 is y minus 75 into 10 into 3. By calculating this formula, we are getting the value of y. So what is the properties of MLE? MLE always, maximum likelihood always follows the consistency matrix. What is consistency? That as the sample size is n goes up to infinity, theta is always tried to, theta MLE is always come near to the true value. It converges the correct answer given through the data. What is asymptotic normality? If the large value is given, then the Fisher information matrix enables the confidence intervals. What is the next one? Asymptotic efficiency. Among all consistent estimators, MLE achieves the smallest possible variance. What is the another is the invariance property. So these are the difference between the MLE, maximum a priori data, and Bayesian. Three are using for the machine learning backbone, but how one is the best? What is the MLE? MLE decides the maximize the data based on the true output. The what is the MAP? MAP maximize the data and it is directly proportional with the probability of data. What is Bayesian? As I discussed earlier, it is depend on the observed data as well as the a priori data. So there is no prior belief in the case of MLE. It doesn't believe any prior experience. MAP includes, as the name suggests, it always includes the prior, but Bayesian is the combination of two. It incorporates the prior data and the whatever the data is true data. It points the estimate only, it points the regularization, it is not pointing any estimation, it gives the distribution of the data set. It can overfit with small n. If the data set is small, we can use MLE. It is the L2 prior, we need the ridge regression model to remove the overfitting problem, and it has the uncertainty quantification. It is simple and interpretable. It reduces the overfitting. It is computationally little tough. So what is the limitations of MLE? It is biased for small samples. It always gives the overfitting problem. It is we have to calculate the local minima every time. If there are the multiple local maxima or minima, the optimization may not give the global result. As I told here, there is an overfitting risk. It is sensitive to the model assumption. Say one model it gives the more output, another model it is not giving the more output, so there is a problem. No uncertainty quantification is there. MLE returns a point, not any quantification is giving. So real world application of MLE is the machine learning, biology, finance, natural language, medical research, and engineering. In the machine learning, in logistic regression, neural network training, and Gaussian mixture model use the MLE as their objective. For the biological machine learning, MLE estimates the mutation rates so that it is the basics of the optimization techniques or the bio-based optimization. It also helps in the finance model, the NLP, natural language processing, medical research, and engineering for the reliability analysis. So in a small discussion, the MLE finds the parameter theta that makes observed data most probable. What is the most probability? Use the log likelihood to convert the product to sum. MLE means the sample mean of normal. Generally, MLE is the 1 by x by for exponential and k by n for Bernoulli. Already we checked with some problems. MLE for linear regression gives the ordinary least squared data. MLE is consistent, asymptotically normal, and efficient, powerful theoretical model. The limitation it is biased and it has the problem of overfitting. And it is the EM algorithm extends to MLE to models the latent or missing variables. Till now, it is the backbone of the machine learning algorithms. Thank you all.